Hello viewers, welcome to my channel where we help students mathematically. My name is Mr. Adebanjo and I want to strongly welcome you to this video. In this video we are going to be discussing extensively on indices. Indices is one of the major topic in mathematics, not only in senior school but also in junior secondary school as well. Because in junior secondary school you will be taught the foundation of indices, and you will now build on that foundation when you get to senior secondary school. So indices is one of the major topic in mathematics as it is related to other topics in mathematics. So your understanding of indices will help you understand logarithm as well. And we also help you to understand other topics in mathematics. So indices is very important uh, topic in mathematics, also in further mathematics as well. And also it's one of the topic that they tend to ask student question from in both a WAEC, NECO, and JAM questions as well. So you would, as a student that of mathematics, you must understand indices. It's a must that you understand indices very well, and that is why we have deemed it fit to explain what indices is all about to you in this video. This video is a bulky video, and it's going to help you a lot. This material is going to help you a lot. So before we get it started, if you are yet to subscribe to this channel, please click on the subscribe button right now on the channel, and share this video, and click on notification button so that you will be notified whenever we post information on this platform as well. Please deem it fit to share this video with other students out there who need this resource materials, and also like the video as well. So like I said, we are going to be talking extensively in this video on indices. We are going to be explaining what indices is all about to you. We are going to give you the various examples of indices, and we are going to tell you all the laws that are applicable to indices, and we are going to explain each of the laws and use them to solve questions. So we are going to solve questions using the law, like I said earlier, step by step. We have a lot of questions to solve in this video, and also you are going to be solving past examination questions that are related to indices. You are also going to be solving further mathematics questions related to indices in this video. So like I said, this video is voluminous, and it's going to really help you understand indices very well, because we are going to explain it like we are going to explain it step by step to help you understand the indices very well. So without wasting much of our time, let's get started. Dear viewers, if death come knocking today, are you sure your soul is safe to go into eternal rest? Are you sure your soul is safe? Are you sure your soul is in the hand of the Savior? Are you sure you are a born again Christian? If your answer is no, today is your day. Make today your day and then reconcile with Jesus Christ, whom is our Savior. He is the only Savior sent to us from God. He is the only Savior sent to us from God to redeem everyone back to God. Jesus is the way, is the only way back to God. There is no other way. There is no other name given to us under the heaven that we should call upon the name of the Lord except the name of Jesus. So if you are heaven laden, Jesus is calling you today. He's the Savior. He can carry your burden for you. He can fine-tune your future. If you lack wisdom, you lack knowledge, you lack understanding, Jesus is the fountain of wisdom, is the fountain of knowledge, is the fountain of understanding. He can give you all these things. If you are being tormented by darkness, Jesus can give you light. He can give you rest. Jesus is the only Savior that can save you from everything you are going through right now. So if you are in sin, if you are already you are in sin, Jesus Christ has come to pay for the price of your sin, All you need to do is to call upon the name of the Lord and you shall be saved. Call upon the name of the Lord today and shall be saved. We are giving, God give us his only begotten Son to die for us, to die for you and I, so that you can be reconciled to Jesus. If you have, if you have made up your mind to call upon the name of the Lord today to get back to Jesus, all you need to do is to bow your head and say this simple prayer of repentance by saying, Heavenly Father and Almighty God, I come before you humbled and sorrowful, aware of my sin and ready to repent. Lord, forgive me for I have sinned before you. Wash away my sin, purify me and help me to turn from this sin. Lead me to walk in your way instead, leaving behind my whole life and starting a new life in you. Lord, you who are loving and just, show compassion upon me. Shower me with your mercy. All this I pray through your Son Jesus Christ, who came to save us from our sin. Amen. I believe as you have said this, the Lord has heard your prayer and He is at the door of your heart right now, and He will come in. And I want to welcome you to being a born again Christian now. After reciting this prayer of repentance, do find a Bible believing church near you and keep fellowshipping with them there, and the Lord will bless you as you do so. Now, like I said, we are going to be talking about indices in this video. Actually, what is indices? How can we identify indices? What is indices and how can we identify one? That's a question we need to ask ourselves. If you remember very well, when you were in primary school, we were taught that there's a number that has something like power. Let's say I have 2 raised to power 2, 2 raised to power 2, or better still, let's say we have 3 raised to power 2, 3 raised to power 2. That 2, the power of 2 you have here is called index, as indices is from the word index. We can regard index as singular and indices as plural. So when you have a number that has power, then that is where indices originate from. When I have 3 raised to power 2, 3 raised to power 2 is saying that 3 in 2 places. That 3 is the base, 2 is the power or index. So 3 in 2 places, that's what that implies. So that 2, which is the power, is also called the index. It's also called what? The index, while the 3 is the base. So we are talking about indices now. We are talking about the number with base and power. Any number that can be represented in base and power is what we are regarding to in indices. An index tells us how many times the base numbers has been multiplied by itself. For an instance, for an example, 5 raised to power 4. 5 here is the base, 4 is the index or power. So 5 is the base, 4 is the what? The index. This 4 is saying that this 5 is to be repeated in 4 places. 5 in how many places now? 4 places. 5 times 5 times 5 times 5. That's what this implies. But under indices, we are talking about number with base and power. This power, which is 4, is also called index. Another name for index is what? Power. If you look at this example, we have a raised to power m. This is talking about a in m places now. A here is the base, m is what? The power or index. So anytime you are talking about indices, we are talking about a number that has a base and power. So technically, every number we are going to be talking about under indices are number with base and power. Am I communicating at all? So indices is from the word index, and index imply power. So there is no power unless there is a base. So since this a is the base and m is the power, so this number is categorized under indices. Am I communicating now? Now we can give the various example of indices, a number with base and power. I can say 2 raised to power 3, which imply 2 in 3 places. I can say p raised to power m. P is the base, m is the power. I can say 4 raised to power 16. 4 is the base, 16 is the power. We're saying that 4 in 16 places. I can say 10 raised to power 2. 10 raised to power 2, 10 is the base and 2 is the power. I can say 25 raised to power 4. Out of 25 raised to power 4, which one is the base, which one is the power? 25 is the base, 4 is the power. We're saying that 25 in 4 places, that is 25 times 25 times 25 times 25. So with this now, I believe you understand the indices. We are going to be talking about number that has base and power. Okay, having understand what indices is talking about now, that we are dealing with number with base and power, the question is how do we relate with these numbers? How do we relate with these numbers? For an instance, when you have a ball plus 2 balls, that should give us 3 balls, because we know that they are likely terms. When I ask x plus 4x, that should give me 5x, because we are dealing with likely terms and we know how to bring them together. But what if I have x plus y? X and y, they are unlikely terms, so we cannot add them together. So x plus y remains x plus y, so we can't add them together. So when we have number with base and power as well, we should know how we are going to relate with them. We can't just relate with them anyhow. When I have 2 raised to power 3 times 2 raised to power 4, there's a way we can relate with those two indices now, or indices. We cannot just relate with them anyhow, and that is why there is laws of indices. Laws of indices are laws that guide our operation on indices. How do we relate with number with base and power? That is what laws of indices is talking about. We are not just to relate with them anyhow, but the laws will guide us on how to relate with number with base and power. So having understand that now, let's talk about the laws of indices. Laws of indices, like I said, it helps us to relate with number with base and power. So without the laws, we may not be able to understand or relate with number with base and power. So we have like 6 laws to talk about in this video, and we are going to be using them to solve problem. The first law we are going to talk about here is the one you are seeing on the screen right now, this law. And what does the law, what does it mean? You can see that we are having a raised to power p multiplied by a raised to power q. You can agree with me that this is talking about a number with base and power, so we are safe to put it under indices. And also this one as well, a raised to power q, we can say it is a number with base and power. A is the base, q is the power. But in between these two numbers now, we are having times in between them. So there should be a way we are going to relate with this kind of expression when we have them. And that's what the law is saying. That when I have a number with base and power multiplied by another number with base and power, and if they have the same base, that's the condition. If they have the same base, then in between them you're having times, then I can pick one of the base and do something to the power, add the power together. So if you pick one of the base, you have a raised to power p plus q. You add the two power together. I hope you understand what you have to say in there. But another thing I want you to know is that it does not end here. I can still have times another number with base and power. Let's say times a raised to power t. That means what do we do? Since they still have the same power and you're having times in between them, what do? You pick one of the base. You have a plus p plus q plus t. Now, if I have times another number a raised to power n, that means I will have plus n again. If I have times another number a raised to power y, that means I will have another plus y as the power as well. So that means this continue. It does not end here. We're just using this as an example. It does not end here. It continue. Are you there with me now? Another thing I want you to know is that we can move from the right to the left. Sorry, from the left to the right and from the right to the left, depending on the question given to us. So if I'm giving a question like this, I can split it to this. Let's say I'm giving 2 raised to power s plus 2. 2 raised to power s plus 2. That means looking like this now. That means I can break down to be 2 raised to power x times 2 raised to power 2, which is something like this. So we can move from the right to the left and from the left to the right. That's why you have equality sign here, depending on what is given to us. If I'm giving a question in this format, I will change it to this format. If I'm giving some question like this, I can break it down to this like as well. Am I communicating at all? So this is the first laws of indices that say when I have an index raised to power, a number with base and power multiplied by another number with base and power, and they have the same base, that's the condition, they must have the same base, and they are multiplied together. I can pick one of the base and add the power together. So let's use this law to solve some question. Look at this example here. We have a raised to power 4 times a raised to power 6. We can see that they have the same base and we're having times here. So we are safe to apply this law now to pick one of the base and do something to the power. We add the power together, and that will give us a raised to power 4 plus 6, and that will give us a raised to power 10, because 4 plus 6 will give us 10. So as you can see that we have been able to apply this law to solve this first question here, and we can see that they have the same base. That's why we are able to apply it. Let's look at this next example. We are having x raised to power minus 3 times x raised to power 8. What can you see? This still look like this law, in the sense that the base is x, the power is minus 3, times this base is x, the power is 8. That means they have the same base, and you're having multiplication between them. So that means you can pick one of the base, which is x, then add the power together. So you have minus 3 plus 8. Minus 3 plus 8 is 5. So they have x raised to power 5, which is talking about x in 5 places. X times x times x times x times x. Are we there? So another example is what you're having here now. You can see that this one is it's more than this one now. You're having 3 raised to power 2 times 3 raised to power 4 times 3 raised to power minus 5. So we can see that they have the same base, and you're having multiplication in between all of them. So what can we do? We can pick one of the base, since they have the same base, then do something about the power. You add the powers together. So you have 3 raised to power 2 plus 3 raised to power plus 4 rather, plus open bracket minus 5. Why did I open the bracket here? You're having plus and minus. You cannot bring them together, so you have to separate them with brackets, so that the one of the sign will be eliminated when we multiply them together. So we have 2 plus 4 to give us 6. Plus times minus will give us a minus. So we have 2 plus 4 minus 5. Then if you simplify that, 2 plus 4 minus 5 give us 1. And 3 raised to power 1 is 3, saying that 3 in one place. So we can see how we apply this law to solve question. Yeah. Let's see the second law. Second law is very like the first law, but the issue is that we are having division instead of multiplication for the first one. So you are still having a number with base and power divided by another number with base and power. And what can we see here? We can see that instead of times you're having division, and you can see that they have the same base as well. Then you can pick one of the base and you do something to the power. Because it's the division, you subtract the power from one another. So you have a raised to power p minus q. Another thing I want you to know is that it also continues. I can have divided by a raised to power t divided by a raised to power n divided by a raised to power let's say y. All you need to do is, so far all of them have the same base and you're having division in between them, so all you need to do is to pick one of the base and subtract all the power. Are we clear? So also we can move from the right to the left and from the left to the right based on the question given to us. If I'm giving question in this format, I can split it like this. If I'm giving a question like this, I can bring it together like this as well. Let's say I'm giving 2 raised to power s minus y. 2 raised to power s minus y. I can break down to be 2 raised to power x divided by 2 raised to power y, to something like this. I hope I'm clear on that. So let's use this law, second law, to solve some questions as well. The first one here, you're having a raised to power 6 divided by a raised to power 3. you can see that they have the same base, and you are having division here. So that means you pick one of the base, like I said here, which is a, and you do something to the power. Because this is division, you subtract the power, 6 minus 3, and that should give us a raised to power 3. And that is talking about a in 3 places, a times a times a. Are we clear? And you can see that we have been dealing with number with base and power, 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 as you can see. Question number B, we have 10 raised to power 9 divided by 10 raised to power 6. I hope you know that this and this are the same thing. This division you are seeing here can be written as this as well. So this is division sign, this is another word, division sign as well. So this one can be written as 10 raised to power 9 divided by 10 raised to power 6. So this and this are still the same thing. So since they are having the same base, which is 10, I can pick one of the base, and you're having division here, so I'll do something to the power. You subtract the power, 10 raised to power 9 minus 6, and that gives us 10 raised to power 3, which is talking about 10 in 3 places, 10 times 10 times 10, and that should give us 1000. Another question is what you are seeing here right now, 3 raised to power 6 divided by 3 raised to power minus 2. That means you can see apply this law, since we are having the same, they are having the same base, and you're having division here. So we pick one of the base, which is 3, then subtract the power. So you have 6 minus, open bracket, minus 2. And you should know the reason why I'm putting this one in brackets, because you're having minus 2 sign here now together. This one sign, this another sign. So you cannot bring 2 signs together. So you separate them with brackets so that they can multiply themselves, and it will eliminate one of the sign. So minus times minus will give us what? Plus. So we have 6 plus 2 here, and that will give us 3 raised to power 8. And 3 raised to power 8 is 6561. We're talking about 3 in 8 places, 3 times 3 times 3 times 3 times 3 times 3 in 8 places. Let's look at this question, last question here, question number D. We have 6 s raised to power 6 divided by 2 s raised to power 3. So this is another question, but if you look at this question, it's quite different from all this one, because look at x raised to power 6 here. It has a coefficient of 6, and 2 this s raised to power 3 has coefficient of 2. But this power 6 is only affecting x. This power of 3 is only affecting x as well. It does not affect 6, it does not affect 2. So how do you simplify this? This you will do as 6 divided by 2, because this is a whole number, another whole number. So you have 6 divided by 2. So you are not going to apply this law to these 6 and 2. No. So the law, because the 6 is not an index, it's not an index. It does not have a power yet. Although it has a power of 1, but 6 and 2 does not have the same base. So you cannot apply this law to this. So you can also, the only thing you can do is that you do 6 divided by 2, which is what you're having here. Then you cannot apply the laws of indices to this s raised to power 6 and s raised to power 3, because they have the same base, which is x. And in between you're having division, then you subtract the power. So you have 6 divided by 2, which is 3. Then s raised to power 6 minus 3, that gives us 3 as well. So you have 3 raised to power, so we have 3x raised to power 3 as well for this. I hope you understand this second law. So let's talk about the third law. The third law says that any number raised to power 0 is 1 mathematically. Any number raised to power 0 is 1 mathematically. So a raised to power 0 is 1, 1000 raised to power 0 is 1, 1 million raised to power 0 is 1 mathematically. So any number that is raised to power 0 will give us 1 in mathematics, according to this law, this third law of indices. So the first example we have here is 1000 raised to power 0, it gives us 1. Let's look at the second example here. We have s raised to power minus 7 times s raised to power 7. You can see that this one does not relate to this law, but it's related to the law that we have talked about before. We have talked about 2 laws before this one. So there's one of the law that is related to what is given to us. We are having s raised to power 7, s raised to power minus 7 times s raised to power 7. Then you can see that we are having times in between them, and they have the same base. So that means you can do something to this one according to the law, the first law we talked about. So that means you can pick one of the base, And because you're having times here, you add the power together. So you have x raised to the power minus 7 plus 7. What is minus 7 plus 7? What is minus 7 plus 7? I'm asking you, the viewers. You are owing somebody 7 naira, and you have 7 naira with you, which is plus 7. If you pay the person the one you are having, that means you'll be having nothing with you. So that will give us x raised to the power 0. So what is x raised to the power 0 according to this law? It is 1. Let's look at this question number C as well. We are having 5 raised to the power x minus 1 times 5 raised to the power 1 minus x. Based on your understanding of the first law, you should know what to do to this one now. Based on the understanding you have gathered so far on the law of indices, you're having a number with base and power, and they have the same base, and you're having times in between them. That means you can do something to them according to the first law. So you can pick one of the base and add the power together. So pick one of the base, which is 5, then you add the power together. You have x minus 1 plus 1 minus x. So if you collect like times, x minus x will give us 0, minus 1 plus 1 will also give us 0. So you are left with 5 raised to the power 0. So you are left with what? 5 raised to the power 0. And what is 5 raised to the power 0 according to this law? It is what? 1. So I hope you understand this, the third law. I hope you understand the third law. I hope you understand this third law we have talked about. Let's go to the next law. Now the fourth law is what we have on the screen right now. And this law is one of the law that usually challenge students. And I don't want you to be challenged with this law, as I'm going to explain in detail how you can interpret this law. You're having a raised to the power minus 1. It says that the answer is 1 over a. How come? How come? A raised to the power 1 is equal to 1 over a. How come do we have that? Now, I want you to understand one thing, that we are still having index, number with base and power. This is the A is the base, and minus 1 is the power. And this minus, or let me go with this base you are seeing here, this A, it literally means A over 1. A over 1. That is what you're having here. A over 1. See it as A over 1. Then this minus is saying that you should inverse A over 1. When you inverse A over 1, what did it give us? That one go up, the A come down. That means you have 1 over A. So what is the meaning of this one here? This one here is the power of A. That means this one literally means inverse of A raised to the power 1. Inverse of A raised to the power 1. That's what this statement, that's what this one means. Inverse of A raised to the power 1. So if I have A raised to the power minus 2 here, if I have A raised to the power minus 2, that means this one is saying that inverse of A squared, or A raised to the power 2. That's what it means. So this minus here means inverse of anything you are given. If you are having raised to the power minus, that minus means inverse. Now this one here is the power of A. So I can say this one means 1 inverse of A raised to the power 1 over 1. So if you inverse A raised to the power A over 1, it will give us 1 over A. Now, as you can see here, I explain it better that this is A raised to the power 1 over 1. So if you inverse that, that should give us 1 over A raised to the power 1. A raised to the power 1 is as A. That gives us 1 over A. So what if I have, okay, look at this now. Let's go look at this. This means A raised to the power minus 1. And what does it mean? It means inverse of A raised to the power 1. What's inverse of A raised to the power 1? That is 1 over A. Because A raised to the power 1 is A. What does this one mean, literally? This one means inverse of A squared. That's what it means. That's how I want you to interpret it. Inverse of A squared. So A squared is same thing as sorry, what am I saying? Inverse of S squared, rather. That's what this one means. S squared over 1 is same thing as S squared. I mean, you know that. S squared over 1 is same thing as S squared, right? Fine. Then inverse s square raised over s square over 1. Inverse it. That gives us 1 over s squared. I hope you understand what I'm trying to say now. This one is saying inverse s square over 1. Inverse s square over 1. That should give us 1 over s squared. Am I clear? So anytime you're having a number with base and power, and the power is having minus in front of it, then that means that minus is saying that you should inverse s squared like this now. Inverse s squared. This minus means inverse s squared. That give us 1 over s squared. Let's look at this now. What does this one mean? This one means you are to inverse 1 over 8 raised to power 1. Inverse 1 over 8 raised to power 1. So if we inverse 1 over 8, what will it give us? 8 over 1. The raised to power this one you are having here. I hope you are clear at all. So what is 8 over 1? It has the same as 8. So 8 raised to power 1 gives us what? 8. So if I invert this question, this one means that you should inverse 8. So if you inverse 1 over 8, that will give us what? 8, literally. I hope you are following, please, because this aspect is the most crucial aspect in indices. If you can interpret this, then you will be able to do a lot of things on indices. Let's look at the next question. You're having 6y raised to power minus 5. This minus raised to power minus 5 is affecting this y only, it's not affecting 6. So that means this can be written as 6 times. If you interpret this y raised to power minus 5, what does it mean? It means inverse of y raised to power 5, which is what you're having here. Inverse of y raised to power 5. What's the inverse of y raised to power 5? That's 1 over y raised to power 5. Then, and if you multiply 6 by 1, that should give us 6 over y raised to power 5. So that means this can be written as this. That's what it implies. So when I have y raised to power minus 5, that should give us the inverse of y raised to power 5, which is 1 over y raised to power 5. Am I clear? Let's look at this. You're having 3s cubed, y raised to power minus 4, z raised to power minus 2. Now there's nothing you can do to this, but you can just rewrite it in another way. What does this one, y raised to power minus 4, what does it mean? I'm asking the listener now. I'm asking you, the viewers. What does y raised to power minus 4 mean? What does z raised to power minus 2? What does it mean? This one literally mean inverse of y raised to power 4, inverse of z raised to power 2. That's what this one means. So this one is 3s cubed, which is this, times inverse of y raised to power 4, which is what you're having here. It's 1 over y raised to power 4. Then times inverse of z square, which is 1 over z square. Does that make any sense to you? So then s raised to s 3s cubed times 1 will give us 3s cubed divided by y raised to power 4 times z raised to power 2. That should give y raised to power 4 z raised to power 2. So if you simplify this, you get this. So literally, when I have a raised to power minus p, what does this one mean? Based on what you have been explaining so far, if I have a raised to power minus p, what does it mean? That should give us an inverse of a raised to power p. Inverse of a raised to power p, that should be 1 over a raised to power p. So I hope you understand this law now, that when I have a raised to power minus e, what does it mean? A raised to power minus e, what does it mean? I'm asking the listener now. That should give us 1 over a raised to power e. If I have 2 raised to power minus 3, who can tell me the answer to that? 2 raised to power minus 3, what will it give us? That should give us 1 over 2 raised to power 3. And what is 2 raised to power 3? That should give us 8. So we have 1 over 8 as the answer. So this is talking about inverse of a raised to power p, inverse of a raised to power 1, inverse of a raised to power 2, inverse of 1 over 8. Then you're having inverse of y raised to power 5, which is 1 over y raised to power 5, and so on and so forth. Do we understand that law? Let's go to the next law. The next law, which is law 5, is talking about a raised to power m, which is talking about a number with base and power, then multiply by another power. This p is a power and m is also power. So when I have a number with base and power and the power is multiply another power, that means this power can multiply this. So you have m times m will give us a raised to power mp. So that means the law is saying that this power can multiply this power. Do we understand this? A raised to power m into bracket raised to power p. So the law is saying that these two powers m can multiply p. So give us a mp. That's another law. So let's see that in action. Example 1, we have x raised to power minus 2 raised to power 3. So according to this law, now that means 3 will multiply, since both this is a power, this is another power. So 3 will multiply minus 2. So we have x raised to power minus 2 times 3. And that should give us x raised to power minus 6. And based on the law we just learned, the law 4 we just learned now, you should be able to interpret what this one means. Based on the law we just learned, not in this one, the one we learned before this, you should be able to interpret this. This one is saying that this man is saying that inverse of x raised to power 6, inverse of x raised to power 6, and that should give us 1 over x raised to power 6. Am I clear? Good. Now let's look at another one. We have been y raised to power minus 2, then raised to power minus 2 again. According to this law, that means minus 2 will multiply minus 2. So we have y raised to power minus 2 into minus 2. So minus 2 times minus 2 will give us what? Plus 4. So we have y raised to power 4 here. Let's look at this example. We are having 2f raised to power 3, then raised to power 2 again. So that we can apply this law. This 2, which is power, will also multiply this power 3. So you have 2f raised to power 3 times 2. And what's the 3 times 2? That should give us 6. So you have 2f raised to power 6. And then look at what you're having here. What does this one literally mean? You're having 2f raised to power 6. That means this power is affecting 2, is affecting 6. It's quite different from the one we saw before. Let's go back. It's quite different from this one. This minus 5 is only affecting y, because you are not having everything. If you are having 6y in bracket, then raised to power minus 5, then it will affect this, it will affect this. But if you look at this now, look at this, where are we? This one now, you're having 2f raised to power 6. That means this power of 6 will affect 2. It also affects f. So what does that mean? You'll be having, of course, you know that 2f it means 2 times f, right? 2f means 2 times f. So you have 2 raised to power 6 times f raised to power 6 as well. So 2 raised to power 6 is 64. That is 2 in 6 places. 2 times 2 times 2 times 2 times 2 times 2. That will give us 64. Then f raised to power 6. I hope you understand this. If you understand it, let's do the d part. You have minus 2 y raised to power 6, then raised to power 4. Can you simplify this? So we know that this power will affect this, will multiply this power of 6, and this power also will affect minus 2 as well, because this 6 is a power of y. So but this 4 is affecting everything inside the bracket. Do we understand that? So what can we say? So you can split this one to be minus 2 raised to power 4 times y raised to power 6 raised to power 4. Do you understand this? So then what does this one literally mean? Minus 2 raised to power 4 means minus 2 in 4 places. Minus 2 times minus 2 times minus 2 times minus 2. And minus 2 times minus 2 will give us plus 4. Then we still have minus 2 times minus 2 again, will give us plus 4. Then 4 times 4 will give us what? 16. Then according to this law, 4 will multiply 6 here because they are both power. So that should give us 6 times 4 will give us 24. So this one will give us 16 y raised to power 24. I hope you understand this law as well. Let's talk about the last law, which is the most crucial aspect of the law. So the law is talking about the square roots. When I have square root of a, what does it mean? Or how can I write square root of a? When I have square root of a, what does it mean? It means a raised to power half. Square root of a means a raised to power half. If you want to write it in initial form, because a is the base, half is the power. So this one is now in initial form. Before it was not in initial form, but now it is now in initial form. So when I see square root of a, I can write it in the initial form to be a raised to power half. How did we arrive at this? Let me try to tell you this. How did you arrive at this? a raised to power half. Look at this. This square root is same thing as when I put 2 inside this arm here. Look at what we have written here. This square root is same thing as 2 like this, then a. This is square root. This is also what? Square root. So if I don't put any 2 here, it is square root. When I put 2 here, it's also what? Square root. Am I communicating? It's different from me putting 2 outside here. You can see this one now. This is 2 multiplying square root of a. This one, this is talking about square root of a because the 2 is inside this arm. So this is square root of a. This one is saying that 2 is multiplying square root of a. So this one and this one, they are not equal. They are not the same thing. But this is square root of a. When I put my 2 inside here, then this is also square root of a if I don't put anything here. Do you understand that? So I will just want to explain how we got this now. Now, how do we arrive at this? So that means there's an invisible 2 here. And that 2 is what you're having here. This 1 here is the power of a. So a raised to power 1 is the same as what? A. So we have, we can say that this is a raised to power 1, then 2 is here. So that a raised 1, the power of a here is this 1, then divided by the 2, which is for the square root. And that what give us this a raised to power half. Okay, what if this is 3, which is cube root? What if I put 3 here? What will it become? If you want to interpret it in an initial form, if this is 3 here, that means you have a raised to power 1 over 3 because the power of a here is still 1, so you have 1 over 3. That's what you're having here. So the cube root of s is, it can be written, if you write it in an initial form, what will it become? You have s raised to power 1 over 3, where 1 here is the power of x, and this 3 is from the cube root. So let's interpret this one in an initial form. Fourth root of s cube. How do you rewrite that? Although you have seen it already. But based on our explanation, you should know that this 3 is the power of x. So you have 3 here over the fourth root, which is 4. So you have s raised to power 3 over 4. Do we understand that? So you have s raised to power 3 over 4. Then literally, when I'm giving n root of a raised to power m, how can you rewrite that in an initial form? How can we write this in an initial form? N root of a raised to power m. That means you have a raised to power m, which is the power of a, over n, which is the root. So you should be able to interpret. So when I'm giving question like this, I should be able to interpret what this one literally means. This one is saying that the n root of a raised to power m, the n root of a raised to power what? M, the fourth root of as raised to power 3, the cube root of s raised to power 1, the square root of a raised to power 1. So I hope you understand this now. So if you understand this now, let's solve some question with this. We are having the square root of 25 b raised to power 4. 25 square root of 25 raised to 25 b raised to power 4. This we can break into pieces. If you understand what I've done here, you can simplify this one yourself. But let's break it into pieces. This can be broken at square root of 25 times square root of b raised to power 4. Are we there? Of course, now if I ask you what is square root of 25, you say it's 5. Fine, that is correct. But how do we come about that 25? This 25, I can change it to an index form. That is, it will have a number with base and power. And that should be 5 raised to power 2. So the index of 25 is 5 raised to power 2. So, and we know what this square root means. What the square root means. That should give us raised to power 1 over 2. So 25 is written as 5 raised to power 2. Then this square root is the raised to power what? Half, based on what you have learned here. So also b raised to power 4 into the square root of b raised to power 4 can be written as b raised to power 4 into what's the meaning of square root? That raised to power 1 over 2. Then according to the law we learned here now, this law we learned here now, let's go back. This power can multiply the power of 2. This half will multiply this 2. So 2 times half will give us what? 1. That is 2 can cancel 2. So we have 5 raised to power 1 left. Then here also 4 will multiply the power of half here as well. 2 here, 1, 2 in 4, that gives us a 2. So you have a 5 raised to power 1, which is 5, times b raised to power 2, which is b square. So that will give us this 5b square. So if you interpret this one, literally mean square root of 25 b raised to power 4. Square root of 25 is 5. Square root of b raised to power 4 is 2. Sorry, square root of b raised to power 4 is b raised to power 2 rather. So let's interpret this next question. What does this one mean? What does this one mean? This means the cube root of 8. Cube root of what? 8. What's cube root of 8? That should give us 2. And 2 raised to power 3 give us what? 8. But if you want to simplify it in an indicia form, how do we go about that? You know that this can be written as 8 raised to power 1 over 3 based on our understanding of this. This cube root can be written as 8 raised to power 1 over 3. Then this power of 3 again. Then according to this, the law that we just learned now before this one, this 3 will multiply 1 over 3. So 3 will cancel 3 here. You have 8 raised to power 1 left. So 3 will cancel 3 as you can see. Then you have 8 raised to power 1 left. So 8 raised to power 1 seems as 8. So look at this question number C. We should be able to interpret this one now. Here we are having uh, two or three laws to solve this question. How? I can interpret this one now because of this minus, this power of minus here. We're talking about inverse of 27 raised to power 2 over 3. I hope you understand that. Based on our law that we have learned so far, this minus here is talking about inverse of 27 raised to power 2 over 3. And what does 27 raised to power 2 over 3 means? Based on what you have learned so far here. What does 27 raised to power 2 over 3 mean? It means that cube root of 27 raised to power 2. I hope you understand what I'm trying to say. What does 27 raised to power 2 over 3? What does it mean? That over 3 means cube root of 27. Then 2 at the top is talking about this power of 27. So you can say that this is cube root of 27 raised to power 2. And then you will now find its inverse, which is because of this minus. So what is cube root of 27? That is 3. Then 3 square is what? 9. Then you find its inverse, which is 1 over 9. That's what you're having here. But if you don't understand that, you can simplify this one using indicia form. How? Convert this one to an index form. Find the index of 27. That should give us 3 raised to power 3. Then put it in bracket raised to power minus 2 over 3. Then according to the law that we have learned, this 2 over 3 will multiply 3. So 3 will cancel 3 here. This 3 will cancel this power 3. So you are left with 3 raised to power minus 2. And according to our law we have learned, this one means inverse of 3 raised to power 2. So 1 over 3 raised to power 2. Then what is 3 raised to power 2? That gives us 9. So we have 1 over 9 left. I hope you understand that. Then look at this, because number D, you should be able to solve this one as well. This one means the inverse of 9 over, so 9s squared over 25. The inverse of square root of 9s squared over 25. The inverse of 9s squared over the inverse of square root of 9s squared over 25. The inverse of 9s squared over 25. That's what this one means. If you want to interpret it literally, the inverse, because of this minus, the inverse of square root of 9s squared over 25. The question is, if I inverse 9s squared over 25, what will it give me? It will give me 25 over 9s squared. If according to this minus here, if I inverse this fraction now, that means I have 25 over 9s squared raised to power half. Why are we not having this minus here again? Because we have already inversed this fraction. So inverse this fraction, you have 25 over 9s squared, then raised to power half. So what does this one means? What it means square root. 1 over 2 means 1 raised to power 1 over 2 means what? Square root. So what's square root of 25? 5. And what's square root of 9? 3. What's square root of s squared? That will be x. So if you don't understand it, you can break it down step by step. You can change this one to an index form. That means you have a 5 raised to power 2. Then change this one to index form. You have 3 raised to power 2. Then you have s raised to power 2 here. Then this 1 over 2 will multiply the power, each of the power. It will multiply 5 raised to power 2. So 2 will cancel 2 here. You have 5 raised to power 1 left. That will give us this 5. Then this half also will multiply 3 raised to power 2 as well. So the 2 will multiply this half as well. Then 2 will cancel 2. You have 3 raised to power 1. That gives us this 3. Then half also will multiply this 2 here also, which is the power of x. Then 2 will cancel 2 as well. You have s raised to power 1. That gives us x as well. So you should be able to interpret all these questions based on my interpretation. So I hope you understand this. Now, based on you have learned all the laws of indices, there are six of them as you have learned so far. Now we want to use all the laws that we have learned so far to solve general questions. So in indices, you are given question on indices. You may use one or two or more laws to solve one particular question. So that's why you are meant to memorize all the laws and you should be able to interpret them so that when you are given a question on indices, you should know which of the law you are to bring out to solve that particular question. Now let's look at this first question, question number A here. You have 2 raised to the power 4 times 1 over 8 raised to the power minus 1 times 4 raised to the power 0. Now there's a law that will take care of this. There's another law that will take care of this for us based on what you have learned so far. So you have to raise to the power 4 times 1 over 8 raised to the power minus 1. What does this one mean based on what you have learned so far? You discover that this one means that you have to inverse 1 over 8 raised to the power 1. Inverse of 1 over 8 raised to the power 1. So what is inverse of 1 over 8? That should give us 8 over 1. So what is 8 over 1? That is what? 8. Then 8 raised to the power 1 is something as what? 8. Then what is 4 raised to the power 0? 1. Because anything raised to the power 0 is what? 1. Are we there? So then 8 times 1 will give us 8. Then we can now change this 8 to index form so that they can have this. It can have the same base with this one. So what is the index of 8? That will give us 2 raised to the power 3. So 2 raised to the power 3 means as what? 8. Then you can now apply the one of the law to this one as well, which is the first law we have learned. Since they have the same base and they are having times here, you can pick one of the base and add the power together. So you have 2 raised to the power 4 plus 3, and that should give us 2 raised to the power 7, which means 2 in 7 places, and that will give us 128. So do we understand? You can see that you have applied like 3 laws to solve this particular question here. Now there's a law that apply to this one, there's a law that's applicable to this one, and we now apply another law here as well to solve this particular question. Let's see another question quickly. You're having 28 s raised to the power minus 5 divided by 12 s raised to the power minus 10. We have to simplify this expression, this initial expression. How do we simplify this? Now we can see that we are having 28 as the coefficient of s raised to the power minus 5. You're having 12 as coefficient of s raised to the power minus 10. So we cannot apply any law to this one and this one, but rather 12 can divide 48 according to this division here. So you have 48 divided by 12. Then you can apply the law to this one and this one, because you're having in a number with base and power and a number with base and power, and they're having the same base here. So you can pick one of the base, and because you're having division here, what do you do to the power? What do you do to the power? Because of this division, you subtract the power. So you have 48 divided by 12, then s raised to the power minus 5 minus 10. I should know the reason why we are putting this one in brackets, because you cannot put two signs together, so they have to multiply themselves so as to eliminate one. So minus times minus will give us what? Plus. So you have 48 divided by 12 will give us 4. Then you have s raised to the power minus 5 plus 10. Minus 5 plus 10 will give us plus 5. So that should give us 4s raised to the power 5 as the simplification of this question. Let's see another question quickly. We are having 10 p raised to the power 5 q r raised to the power 3 divided by 5 p raised to the power 3 r. So you should be able to interpret this question. This 5 is the power of p, it does not affect 10. This 3 here is the power of r, it does not affect q. Likewise, this 3 is the power of p here, it does not affect r. So what do we do? So this is a whole number, another whole number. So that means they divide themselves. 10 divided by, because of this division, 10 divided by 5, that's what you're having here. Then since we have q here and there's no q here, so there's no, you cannot apply law to that. You cannot apply any law to that. So you can put down here q. But you're having p raised to the power 5 here, you're having p raised to the power 3 here. So that means you can apply the law of indices to this, because you're having the same base pp and then you're having division. So that means what do you do to their power? You subtract their power, 5 minus 3. You're having r here, you're having r here as well. And the r here is having power of 1, as you know. So you can also apply the law of indices to that as well. So you have r raised to the power 3, and because of this division, you subtract their power. So the power of r here is 1. So you have r raised to power minus r raised to power 3 minus 1. So 10 divided by 5 give us 2. Then p minus 3 is 2. Then 3 minus 1 is also what? 2 as well. So that gives us 2q p square r square. So when you simplify this. Okay, let's see another question very well. You're having 9s cubed y raised to power minus 4 divided by 3s y raised to power minus 4. Now, if you are smart with your in thinking, then you should be able to simplify without going through this stress. But because you are a learner, that's why we are taking you through this long step. Now, I can apply 3 can go in 9. That give us 3. Then x in s raised to power 3, that should give us s raised to power 2. Then you're having y raised to power minus 4. Then divided by y raised to power minus 4 also. So that gives us y raised to power 0. Then y raised to power 0 is 1. Then that means you have s raised to power 2. So 3s raised to power 2 as your answer. But let's take you through it one after the other. So I can write this one as 9 over 3 like this. Then you have s raised to power 3 times there's 1. This because this s is under the division, you can write it as 1 over s raised to power 1 over s rather, because this x you are seeing here, this x under here is it can be written as 1 over x, which is this one, then times y raised to power minus 4, which is the one at the top, times this one also, this y raised to power minus 4 under here can be written as 1 over y raised to power minus 4. Do we understand that? Good. So then 9 in 3 in 9 give us 3. You have s cubed here. Then according to our law of indices, this 1 over s, which is talking about inverse of s, can be written as s raised to power minus 1. You remember the law that say that this one, if I have a raised to power minus 1, can be written as 1 over x. So when I have 1 over s as well, I can write as s raised to power minus 1. So 1 over s is same thing as s raised to power minus 1 like this, times you have y raised to power minus 4, times this one can be written as this one is taking the inverse of y raised to power minus 4. So according to that law, this one can be written as y, then this you have minus into bracket minus 4. So this minus is inverse. You have here this inverse. So y minus into bracket minus 4. Then if you open those brackets, or better still, this one and this one, you can apply the law of indices to this and this, because you're having a number with base and power, number with base and power, so you're having the same base. So what do? You can pick one of the base and add the power together. So you have s raised to power 3 plus minus 1. So plus times minus will give us minus. So we have s raised to power 3 minus 1. Then also you can also apply law of indices to this as well. You have y raised to power 4 plus then minus 4 according to what you're having here. Although minus times minus will give us plus. So minus times minus will give us plus as well. So you are left with a 3 minus 1 will give us a s raised to power 2 here. Then y raised to power minus 4 plus 4. Minus times minus will give us plus. So you have a y raised to power minus 4 plus 4. So y raised to power minus 4 plus 4 give us y raised to power 0. And then 3 raised to power 0 is what? Is 1. So you have left with a 3s squared times 1. And that give us 3s squared. So if you the step-by-step procedure here should help you understand, but this can be done smartly, like the way I did it in the first place. Let's look at this question as well. You're having 1 over 3 raised to power 5n times 9 raised to power 3 and 9 raised to power n minus 1 times 27 raised to power n plus 1. How can we simplify this initial expression? According to the law of inverse, this can be written as a 3 raised to power minus 5n. I hope you understand. Because this man is saying that the inverse of 3 raised to power 5n, which is this. So that means this one also can be written as this one according to the law. I hope you understand that. Then we can change this 3 to an index form. That will give us 3 raised to power 2 into bracket this power n minus 1. We can also change 27 to an index form, I give us 3 raised to power 3 into the bracket of the power n plus 1. And according to the law of power, these two multiply this bracket as well. And these three will multiply the bracket according to that one of the law that the two power can multiply themselves. So that means you have 2 into 2 times n will give us 2n, 2 times minus 1 will give us minus 2, 3 times n will give us 3n, then 3 times 1 will give us, oh, excuse me, there's an error here. This is 3 times 1 to give us 3, not 1. That's a typographical error from my side. So you have 3 times n to give us 3n, then plus 3 times 1 will give us 3. So this is 3. You can correct that from your own part. This is 3, not 1. I hope you understand that. So then what can you do to all this now? You can see that they are having the same base and they are having times in between them. So that means you can pick one of the base according to the first law of indices and they add the powers together. So that's why you pick one of the base here, 3, then minus 5n plus 2n minus 2 plus 3n plus 3. This is 3, not 1. So then you cannot collect like times. Minus 5n plus 2n, that should give us a minus 3n. Then minus 3n plus 3n, that should give us 0. So we are left with a minus 2 plus 3. Minus 2 plus 3 will give us a 1. So you are left with 3 raised to power 1, not 3 raised to power minus 1. You are left with 3 raised to power 1. So the answer is 3, not 1 over 3. I hope you understand that now. The answer is 3, not 1 over 3. So we are having minus 5n plus 2, and that will give us minus 3n. Minus 3n plus 3n will give us 0. Minus 2 plus 3 will give us 1. So we are having 3 raised to power 1, which is equal to 3. So help me correct the answer, the error there, please. Let's look at this question number F as well. Still on indices or indicial expression. Now you're having 27 raised to power 2 over 3. You should be able to interpret this one by yourself based on what you have done so far. This one is talking about the cube root 1 over 3, cube root of 27 raised to power 2, cube root of 27 squared. And what is cube root of 27 squared? Cube root of 27 is 3. Then 3 squared will give us 9. So that way you're having 9 here for this one. You should be able to interpret this as well. This one is talking about the inverse of square root of 64. Because 1 over 2 here, this half here means square root of 64, and this minus here means inverse. So what is square root of 64? That will give us 8. And what is inverse of 8? That will give us 1 over 8. That's what you're having here, 1 over 8. You should be able to interpret this one as well. This one is talking about the inverse of fifth root of 32 squared. The inverse of fifth root of 32 squared. What is fifth root of 32? That is 2. Then 2 raised to power 2 is 4. Then what is inverse of 4? That gives us 1 over 4. So you can see everything here is what you're having here. And from there you can simplify further. But we want you to know how to do it in an indicial form. How? You can find the index of 27, which is 3 raised to power 3. Then that 3, the power here will multiply this power here as well, according to the law of indices that we have learned. Then you can also change this one to an index form, 64. That should give us 8 raised to power 2, or 4 raised to power 4 raised to power 4, or you can say 2 raised to power 8. So to tell you 2 raised to power 8, no, 2 raised to power 2 raised to power 5. No, 2 raised to power 6 rather, sorry, 2 raised to power 6. So 2 times 2 is 4, times 2 is 3, times 2 is 8. So 2 times 2 is 4, times 2 is 8, times 2 is 16, then times 2 is 32, then times 2 is 64. So 2 raised to power 6 now will give us this. So anyone you use, whether it's 2 raised to power 6 here for 64, or 8 raised to power 2, or 4 raised to power 3 rather, 4 raised to power 3. 4 times 4 is 16, times 4 is 64. So anyone you use, you still work. So here we use 8 raised to power 2 into brackets 1 over 2 minus 1 over 2 rather. Also the denominator, you can change the 32 to index form as well. So that gives us 2 raised to power 5. into bracket the power here minus 2 over 5 as well. Then according to the law, you know that this power will multiply this power. This power also will multiply this power. This multiply this power as well. So 3 will cancel 3. 2 will cancel 2. 5 will cancel 5. So you are left with 2 raised to power 3. And you are left with 2 cancel 2. You are having 8 raised to power minus 1 left. 5 cancel this. Then you are having 2 raised to power minus 2 left. So 3 raised to power 2 is 9 times. This one is saying that what does this one means? 8 raised to power minus 1. What does it mean? 8 raised to power 1. 8 raised to power minus 1. What does it mean? It means a inverse of 8. Inverse of 8 raised to power 1, which is inverse of 8. And that should give us 1 over 8. What does this one means? 2 raised to power minus 2. That is inverse of 2 squared. Inverse of what? 2 squared. And that's 1 over 2 raised to power 2. So that should give us 9 times 1 over 8 over 1 over 2 raised to power 2 is 1 over 4. Then this one can be written as 9 times 1 over 8. Then this divided can be written as this 1 over 4. And we know that you can change this one to times. This one go, this one come down. So you have 9 times 1 over 8 times 4 over 1. 4 can go in 8. So that should give us a 2. Then you're left with 9 over 2, which can be written as a 4 over 1 over 2. So these are things we can do under using the laws of indices that we have learned so far. Let's see another question here. Question number G. We are having 4 over 25 raised to power minus half times 2 raised to power 4 divided by 5 over 2 raised to power minus 2. Now, based on our idea of indices, we should interpret this. The raised to power half means square root. So you're having the inverse of square root of 4 over 25. Because of this minus here. The inverse of square root of 4 over 25. What if you inverse this? If you inverse 4 over 25, what will it give us? 25 over 4. If you now find the square root of 4, what is 2? Which is 2. Square root of 25 is what? 4. Square root of 25 is 5 rather. So that should give us 5 over 2, which is what you're having here. Then also this one as well. Inverse of 5 over 2 raised to power 2. Inverse of 5 over 2 raised to power 2. If you inverse 5 over 15, that's a 5. 15 over 2 rather. Inverse of 15 over 2 raised to power 2. Pardon me for that. Then what is inverse of 15 over 2? That gives us 2 over 5. 2 over 15 rather. Then raised to power 2. So then if you don't understand that, then we can still do it in a usual way. According to this is the inverse. So inverse this, which is 24 over 4. We're left with the raised to power half times 2 raised to power 4 is 16 divided by, if you inverse 15 over 2, that gives us 2 over 15 then squared. Then what is the square root of 25? That gives us 5. Square root of 4 is 2 times 16 divided by, this one gives us 2 square is what? 4. 15 square is what? 225. Then you can change this division to times. That should give us this come down again. That means give us 225 divided by 4. Do we understand that? Good. Now if you do that, 4 can go in 16 4 times. 2 in 4 will give us 2. Then 2 times 5 times 225. That's what you're having here. And that should give us 2250. Let's look at this question number H. You're having 0.027 raised to power minus 1 over 1 over 3. And how can we interpret this? Of course, this question is on indices because this is a base and this is a power. So we can change this power to improper fraction. And how do we do that? This is 3 times 1 give us 3 times plus 1, that gives us 4 over 3. So you have minus 4 over 3. And we can also change this fraction to, we can also say this decimal number to fraction. And that should give us 27 over 1000. Move the decimal point 1, 2, 3. That gives us 27 over 1, 2, 3 for the 0. So 1000. Then raised to power minus 4 over 3. So, and because of this minus here, it's talking about, you're saying that you should inverse this fraction, inverse it. That should give us 1000 divided by 27 raised to power 4 over 3. Then you should be able to interpret this. This is the cube root of 1000 raised to power 4. Cube root of 27 raised to power 4 as well. But if you don't understand that, You can change this one to index from 1000, that give us 10 raised to the power 3. Change 27 to index for that give us 3 raised to the power 3. Do we understand that? Then this power will multiply the numerator, also multiply the denominator. You have this and this. Do we understand that? Then 3 will take care of 3 here, so you have 10 raised to the power 4 left. This power also will take care of the power here according to the law that say the power can multiply. Then you have 3 raised to the power 4 also here. 10 raised to the power 4 is 10,000. 3 raised to the power 4 is 81. And if you divide this, you have 123 whole number 37 over 81. So you can see how you apply the laws of indices to solve all these questions you have been solving so far on indicial expression. So if you understand all the questions you have solved so far on indicial expression, you can try to simplify this based on your own understanding. Try all these 4 questions and you can leave the answer in the comment section of this video, and now I will get back to you on it to help you know whether it is you are correct or not. So before we continue on the indicial equation, if you are yet to subscribe to this channel, please click on the subscribe button right now so that you will be notified whenever we post information on this platform. You can also like the video and share the material with students out there. Now that we have talked about all what we have been talking about so far are indicial expression. They are not equation, but there are some equations that are also related to indices, and we call them indicial equations. Equations that are related to what? Indices. We call them indicial what? Equation. An example is what you're having here on the screen right now. Solve the equation 3x raised to the power 1 over 5 equal to 6. You have to find the value of x in this case. You should be able to interpret this. What does this x raised to the power 1 over 5 means? And that is the reason why this is an indices. This equation is an indicial equation because of this x raised to the power 1 over 5. This is a base, this is what? This is power. So you should be able to interpret this, that this one is talking about the fifth root of x. X raised to the power 1 over 5 means fifth root of what? X. So then what can we do? We can divide both sides by this 3. So 3 here, 3 cancel here, 3 in 6 will give us 2. Then look at this now, we're having the fifth root of x. Fifth root of what? X. How can we remove this fifth root of x? So if I have square root, how can I remove square root? I will square that square root. It will remove the square root. If I have cube root, how can I remove cube root? I will cube it. If I have fourth root, how can I remove fourth root? I will fourth it. If I have fifth root, how can I remove fifth root? I will fifth it. So here we are having fifth root. I want to find our x. How do we eliminate it? So that means we are going to fifth it. But that is, take the raised to the power 5 of this. So you're having x raised to the power 1 over 5, then raised to the power 5. And whatever you do to the left hand side, you do to the right hand side because this is an equation. So 2 raised to the power 5 as well. Then according to the law of indices, this power will multiply this power. For 5 we cancel 5. You are left with s equals to 2 raised to the power 5, which is 2 raised to the power 2 in 5 places, and that gives us 32. So our s is 32. Our s is what? 32. How can we confirm that? If I put my x here, that means I have 32 raised to the power 1 over 5. What is fifth root of 32? What is fifth root of 32? That's give us 2. Then 2 times 3 give us what? 6. That shows that this is what? Correct. Let's look at this as well. You're having x raised to the power 2 over 3 is equal to 36. You are looking for value of x. So how do we remove the cube root of s square? Because you'll be able to interpret this one. This one is talking about the cube root, which is 1 over 3, then s square. Cube root of s square. How do we remove the cube root of s square? It's very simple. Since I have cube root, I can cube this to remove the cube root. So that means take the cube of both sides. That is like this. Time you have s raised to the power 1 over 3, then raised to the power 3. Then also you keep this one, because what you do to the left hand side, you do it to the right hand side as well. Then that means this 3 will take care of the cube under. So you have s squared left. Then 36 cube will give us 46,656. Then how do I remove square here? Because I'm looking for x. So that means you can take the square root of both sides to remove the square. So s equals to square root of 46656. That will give us 216. So our s is equal to 216 for question number B. Let's see another question on indicial equation. You're having 16 raised to power y equals to 0.125. 16 raised to power y equals to 0.125. How can we simplify this? 16 raised to power y is equals to, you can change this one to a fraction. That gives us 125 over 1000. Then 125 can go in 125, that gives us 1. 125 in 1000 give us 8. And according to the law of indices, this can be changed to 8 raised to power minus 1 based on what you have done on inverse of laws of inverse. So this one means 8 raised to power minus 1. Then from there, we can now change this one to, you can take index, you can find the index of 16, that gives us 2 raised to power 4. And that 4 multiply y, that gives us 2 raised to power 4y. Then you can find the index of 80 as well, that gives us 2 raised to power 3. And that 3 will multiply minus 1, that gives us 2 raised to power minus 1, minus 3 rather. Then 2, since we are having equation here now, this you're having this base can take care of this base, and only if you're having a single index here, another single index here, and they have the same base, so that means the base can cancel the base. So we have 4y equals to minus 3. They can divide both sides by 4 to get y to be equal to minus 3 over 4. Let's look at this question as well. You're having 4 raised to power 3n plus 1 times 64 raised to power n minus 2 equals to 1. We have to look for the value of, we have to find the value of n, because this is an equation. So what do? We can see that can we apply any law of indices to this? No, since they don't have the same base. But we can find the index of 64 so as to make this have the same base. The index of 64 is 4 raised to power 3, then into bracket n minus 2. And you know that this 3 will multiply, you open a bracket according to the law of indices, that the power here will multiply this power. So we have 3n minus 6. 3 times n will give us 3n. 3 times minus 2 give us minus 6. Then look at this side now. You can now apply the law of indices to this now, because they're having the same base. They're having times here. So you can pick one of the base and add the power together according to the first law of indices. So you have 4 raised to power 3n plus 1 plus 3n minus 6. So this 1 here can be changed to 4 raised to power 1, being that anything raised to power 0 is what? 1. And why are we choosing 4 raised to power 0? Because we want the base to be equal. So I mean this one is 2 now. That means we need to change this one to 2 raised to power 0 as well. So we want the base to be equal. So that's why we chose 4 raised to power 0 to be 1. So 4 can take care of 4 now, because you're having a single index here now. Because everything here is a power of 4 and a single index here. So 4 can take care of 4 as the base. You can now simplify this. We have 3n plus 3n, that will give us 6n. 1 minus 6, that will give us minus 5, equals to what? 0, which is the power of this, because 4 will take care of 4 here. So you can collect light time from there. Minus 5 come here. You have 6n equals to 5. Divide both sides by 6 to get n. N will equals to 5 over 6. Let's look at this question as well. You have to solve 1 over s, it's 1 raised to power s minus 2 equals to 27 raised to power 1 minus x. This can be done in different ways. We know what this one means. This one is talking about inverse of 81 s raised to power minus 2, which can be written as 81 raised to power minus open bracket s minus 2 equals to 27 raised to power 1 minus x. You can now find the index of 81 and index of 27 so as to take care of the base. Another way you can solve it is that you can cross multiply. Since this is a fraction, this 1 over this is a fraction, you can cross multiply. So that means 81 raised to power s minus 2 will multiply this. So you are left with 1 is equals to 27 raised to power 1 minus x times 81 raised to power s minus 2. Do we understand that? Then from there, you can change this to an index form, 81 to index form. So you have 3 raised to power 3 for 27 into 1 minus s times 3 raised to power 4 into s minus 2. Then this 3 will open the bracket. You have 3 raised to power 3 minus 3x times 3 raised to power 4, multiply the bracket, you have 4s minus 8. Then look at this side now, you can apply the law of indices here. The first law, this and a number with base and power multiplied by a number with base and power, and they're having the same base 3 3, so you can pick one of the base and add the power together because of these times here. So you have 3 raised to power 3 minus 3s plus 4s minus 8. Are we there? So 3 minus 4s plus, sorry, minus 3s plus 4s will give us x. Then 3 minus 8 will give us minus 5. So we are left with 3 raised to power s minus 5. Then this can be changed to 3 raised to power 0 to be equals to 1, because any number raised to power 0 is 1. And why are we choosing 3 raised to power 0? Because the base here is 3, so we can choose 3 as well so that they can cancel out. Then you are left with 3 minus 5, sorry, s minus 5 is equals to 0. Then from there, can find our s by collecting like time. So s will be equals to 5 in this case. So let's look at this question again on indicial equation. Look at this as well. What do you think we can do? This is a fraction, we can cross multiply as well. So you have 9 raised to power 4s plus 1 multiplied by, because if you cross multiply, this one goes here. This 3 raised to power s will multiply this one. So we have times 3 raised to power s equals to 81 raised to power s minus 3. Because 81 raised to power s minus 3 will multiply 1 under this one here, under this one. So there's over 1 here. So this one multiply that one, this one multiply this. So you have this. So this now you can change to index so that they can have the same base. So you have 3 raised to power 3, 3 raised to power 2 to give us this 9. Then into bracket 4s plus 1 times 3 raised to power x. You can change this h1 to index form, so that give us 3 raised to power 4 into 3 minus s minus 3 rather. Because 3 raised to power 4 is 81. 3 times 3 times 3 times 3 in 4 places will give us 81. Then these two will open the bracket according to the law of indices. 2 times 4 will give us 8s. 2 times 1 will give us 2. Then 4 times s will give us 4s. Then 4 times minus 3 will give us minus 12. You can now apply the law of indices to the right hand side here because you're having this times this. So you can apply the first law, pick one of the base, add the power together. You have 3 raised to power s, 3 raised to power 8 plus 8x plus 2 plus x. That equals to 3 raised to power 4s minus 2. What can we do? A single index here, a single index, so they can cancel, the base can cancel out since they have the same base. So you are left with 8s plus x will give us 9x plus 2. Then 4x minus 12. Collect like times 4s comes here, you have a 9s minus 4s, that gives us 5x. 2 comes here, you have a minus 2 minus 12 minus 2, that gives us minus 14. Divide both sides by 5, that should give us a minus 14 over 5. S to be equal to minus 2 over 4 over 5 as the improper mixed number. So if you understand the initial equation we have solved so far, you can try this question 1 to 5 on your own to find the value of x in each of the case. Then you can also contact me in the comment section of this video to drop your answer so as to know whether you are right or wrong. So that's for that on the initial equation. There's also further questions that could be given to you on indices, and those questions are related to further mathematics or sometimes in general mathematics. Let's look at them quickly. Let's look at this question. You have to solve the following exponential equation. Now we are having 5 raised to power 2x minus 26 into bracket 5 raised to power s plus 25 equals to 0. You are having a number with base and power, But if you look at what you're having minus, you're having plus. There's no law that says, there's no law that can help us take care of this. There's no law we can apply to this yet right now, based on the law we have learned so far. Then how do we solve this? Now, I can change this 5 raised to power 2s to 5 raised to power x, then to bracket raised to power 2. Why did I do that? I want this to look like what you have inside this bracket. I want this bracket and this bracket to be equal. And why if according to the law of indices, this x times 2 give us a 2x because this power can multiply this power. So you see have this 2x back. So this 5 raised to power 2x back. So that means I can rewrite this one like this 5 raised to power x into brackets 2. Do you understand that? So you write this one again. Then you can see that we're having this bracket and this bracket, they are equal. So we can replace this bracket and this bracket with something else. You can say let y be 5 raised to power x. So anyway, I see 5 raised to power x here, I will put y there. So I have y squared, because this is a y, I have y squared minus 26, this is also y, plus 25 equals 0. So if you are a student that have gone through quadratic equation, you will know that this is a quadratic equation now. But if you are not a student that have gone through quadratic equation, this equation is called a quadratic equation. A quadratic equation is an equation with the highest power of the unknown to be 2. A quadratic equation is an equation with the highest power of the unknown to be 2. This unknown here, the power of the unknown here is 2. The power of this one is 1. So the highest power here is 2. So this is a quadratic equation. And that means if you solve this quadratic equation to get the value of our y, you can now come back to get the value of our x, because in this equation you have to find the value of x, not y. We are the one who invented y into this equation by replacing 5 raised to power x to be what? Y. So let's solve this quadratic equation. There are different methods of solving quadratic equation. We have factorization method, we have completing the square method, we have a formula method, and we have graphical method. But in this video, we are going to use factorization method. We're going to use factorization method. How do we do that? We look for two numbers we can multiply together to give us plus 25. And when you add those two numbers together, it will give us minus 26. I will come again. Look for two numbers you can multiply together to give us plus 25. And when you add those two numbers together, it will give us a minus 26. So what are those two numbers? We have minus 25 and minus 1. Minus 25 times minus 1 will give us a plus 25, because minus times minus will give us plus. Then minus 25 plus minus 1 will give us what? Minus 26. Minus 25 plus minus 1. Minus times plus will give us minus. So we have minus 25 minus 1. That gives us minus 26. So those two numbers are minus 25 and minus 1. So what do we do with those two numbers? Those two numbers will replace this minus 26y here. So you have minus 25. You put y at the back. Then minus 1 y at the back. So 1 times y will give us y. Then plus 25 equals to 0. So those two numbers we talk about here are the one. These are the two numbers here. So we are putting y in at the back of them, because minus 25y minus y will give us minus 26y. Do we understand that now? Then you can now factorize these two and factorize these two. What do you mean of factorize? Bring out the common term between them. Y is here, so y is common. So bring out the y outside. So into y in y squared will give us y, minus y into 25y will give us a 25. So also this one and this one as well. Factorize is something is common between this and this as well. Minus 1 is common. Minus 1 is common to this and this. So if you bring out minus 1 into, so minus 1 in the minus y square minus y, that gives us y. The minus 1 in plus 25, that gives us minus 25 is equal to 0. So when you are solving quadratic equation using factorization method, these two brackets are meant to be the same. You can see these two brackets are meant to be the same. So what do you do from here? Y and minus 1, you pick them together, you give us y minus 1. Then you pick one of the brackets, y minus 25 is equal to 0 as well. So what does this one mean? It means y minus 1 is equal to 0, or y minus 25 is also equal to what? 0. So you can find your y from there. Take this one to this side, you have y is equal to 1. Or take this one to this side, you have y is equal to what? 25. So now you know the value of our y to be 1 and 25. So you can find the value of our s from there. So recall that y is equal to 5 raised to power s, which is from here. So our y is 1 here. When our y is 1, so put 1 here. So you have 1 is equal to 5 raised to power x. So this one is basically on what you have done on previous initial equation. So you can change this one to 5 raised to power 0 so as to cancel the base, because 5 raised to power 0 is 1. So 5 cancel 5. So you have s to be equal to 0. Also, y is equal to 25 here. So this is wrong. y is equal to 25, not x equal to 25. Y is equal to 25. So replace down with here. So you have 25 is equal to 5 raised to power x. Change this one to index form. You have 5 raised to power 2 equals to 5 raised to power s. So base can cancel the base. So s is equal to 2 as well. So our s is either 2 or s is equal to 0. So for this question we are solving, s is either 2 or s is equal to what? 0. So you can confirm your answer. Put your 2 here. Put your 2 here and simplify this. It should give you 0. Or put your 0 here. Put your 0 here and simplify this. Give you 0 as well. That's how to verify whether you are right or wrong. So this one is not x. This is when y is equal to 25, not x. So you can correct that on your own part as well. Let's see another question on that as well. This question is very similar to the one we just solved now. We are having 2 raised to power 2x plus 2 raised to power s plus 1 minus 8 is equal to 0. How do we simplify this? Now, this 2 raised to power 2s plus this one, they have applied the first law of indices to this. Like I told you, under the first law of indices, depending on what is given to you, can break this one down to 2 raised to power x times 2 raised to power 1. So if you apply the first law of indices to this one, it will give you this one back. Do you understand this? Because they have the same base. Pick one of the base, which is 2. Then you having times here. You add the power together. You have s plus 1, which is what you're having here. So this one, we broke it into this 2 raised to power s times 2 raised to power 1 according to the law of indices, which give us this one. Then minus 8 is equal to 0. Then what can we do? This can be written as 2 raised to power x raised to power 2, because this time this will give us 2x back. Do you understand this? Then 2 raised to power 1 is 2. Then 2 times this will give us 2 into bracket 2 raised to power x minus 8 equal to 0. So you can see that this bracket and this bracket are equal. So you can represent it with another variable. So they say let p equals to 2 raised to power x. So that means this one so we'll be having p squared plus 2p minus 8 is equal to 0. And this is also quadratic what? Equation that we need to solve. Now, what do? Look for two numbers you can multiply together to give us minus 8. And when you add those two numbers together, it will give us plus 2 here, which two numbers you can multiply together with their sign to give us a minus 8. And when you add them together, give us plus 2. What are the two numbers? That is plus 4 times minus 2. Plus 4 and minus 2. Plus 4 and minus 2. What is plus 4 times minus 2? That will give us minus 8. And what is plus 4 minus 2? Or plus 4 plus minus 2. When you add them together, plus 4 and plus minus 2. Plus times minus will give us minus. So we have 4 minus 2. That will give us what? 2. So that means those two numbers are plus 4 and minus 2. Then those two numbers will now replace this plus 2 here. So you have plus 4p minus 2p minus 8 is equal to 0. Because plus 4p minus 2p will give us what? Plus 2p. So those two numbers we got there before, plus 4 minus 2 are this and this. We have now added our variable p and p to the back of those two numbers, so that when you add plus 4p minus 2p will give us a plus 2p. Do we understand this now? So this 4p minus 2p is replacing this plus 2p. Now we can now factorize this and factorize this. Something is common to this and this, which is p into bracket p plus 4. Something is common here as well. Minus 2 is common. Minus 2 is what? Common. So you have minus 2 into p plus p, not minus p. Minus 2 into in minus 2p, that will give us p. Minus 2 in minus 8, that will give us plus 4 equals to 0. Because this bracket and this bracket are meant to be equal. So this is typographical error as well. This is plus, not minus. So what do? Pick one of the pick p and minus 2, that give us p minus 2, and pick one of the bracket, which is p plus 4 equal to 0. What does this mean? This p minus 2 is equal to 0, or p plus 4 is equal to 0 as well. From there, collect like times minus 2 comes here, you have p is equal to 2. Pick this one to the other side, that means you have p to be equal to minus 4. So now that we know the value of p here, we can find the value of our x, because we are literally looking for the value of x, not the value of p. So we are the one who invented p to be able to get x. So now that we know the value of p here, we can now return it back here. So record that p is equal to 2 raised to power x. So when p is equal to 2, so you return that here, 2 equals to 2 raised to power x. So this 2 is same thing as 2 raised to power 1. If you change to an index form, 2 raised to power 1. So that means the base and base are equal, so you cancel the base. So you have s to be equal to the power, which is 1. So then when p is equal to minus 4, this one does not have a solution. So because if you put minus 4 here equals to 2 raised to power s, you cannot change this one to index form. You can't say that this one is minus 2 raised to power 2. So because of this minus that is here, that means there's no minus here. That means you'll be having 2 raised to power 2 equals 2 raised to power s, then 2 can cancel 2. But because of this minus here, this one does not have what solution. Therefore, our s is only 1. So this one only have one answer, not two answers. Does that make any sense to you? So also, if you understand those two questions that we have just solved, you can try these two questions on your own as well, so as to freestyle and see how far you can go on indices. So those are the things that we have for you in this video. Thank you for listening. I hope you have been able to learn one or two things in this video. And if you have learned one or two things in the video, please, if you are yet to subscribe to the channel, click on the subscribe button on the screen in the channel right now, so that you'll be notified whenever I post information on this platform. You can also click on the notification button as well, so it will be notified when we post video on this channel. Share the video, like the video, and I will see you in the next video, which is on logarithm. Thank you and God bless you.